Hi, my name's Joe Jackson. I'm a technical sales engineer for Chicago Pneumatic Tool. And today I'd like to take some time and go over some basics when you're selecting a screwdriver. When you're selecting a screwdriver, there's some key things that you want to look at. You want to look at the specifications of the screwdriver, what type of screwdriver it is, and we're also going to talk about clutch type, application, and joint type. Our portfolio of screwdrivers consists of a pistol style and an inline style. A pistol style is generally used for horizontal applications and an inline is generally used for vertical applications. The foot-pound torque range of our screwdrivers range from 0 to 10 foot-pounds, and the free speed on the screwdrivers range from 800 to 1800 RPMs. When you're selecting a screwdriver, there's three basic steps that you want to go through. Step one is you want to understand the application you're utilizing the screwdriver for. Do you need to have precise accuracy and torque? What speed do you need? The next step would be looking at the material that you're using. Is it going to be wood or sheet metal? What type of screws that you're going to be using? And the third step, obviously, is what type of clutch type that you're going to need. And we offer three clutch types: a direct drive, a cushioned, and a shut-off clutch. If you take these three basic steps, this will help ensure that you get the right screwdriver for the job that you need to do to get the maximum performance out of that screwdriver. As mentioned previously in the video, there are three types of clutches that are associated with screwdrivers. And the first one I'd like to talk about is the direct drive screwdriver clutch. The thing that makes this clutch unique is that it's a one-to-one relationship. The motor end is connected directly to where the bit goes. Some of the applications that this tool can be used for is in wood making, potentially cabinetry. It can be utilized with wood screws, self-tapping screws. I have an example right here of a 2811 direct drive screwdriver, and we'll be showing here right now how to adjust the torque on that. We're going to demonstrate the direct drive screwdriver in a trailer manufacturing application. The first step in the process is to adjust your air pressure, and we're going to begin at adjusting at 50 psi. With the PSI set at 50, you can see that we don't get the clamping force to cause the material to join properly, and it took a long time to insert the screw. Now we will go ahead and increase the air pressure up to 70 PSI, and we will see the outcome of that. As you can see at 70 psi, it was much quicker to fasten the material together, and the material was joined properly at a balanced speed. Although the speed at 90 plus psi was much quicker, it was too much speed, which caused the screw to strip on the back side of the material, and it also damaged the fastener. Next, I'd like to talk about the shut-off clutch. And the unique thing about a shut-off clutch is that it has a high rundown speed that is utilized in the applications that you see here, like in aerospace or heating and air conditioning. And the reason we like these shut-off clutches is you need precise accuracy and torque when you're working in those applications. For example, I have a CP2611 I'd like to show you. And the next step will be to show you how you manually adjust the torque on the 2611. Process is very simple. All you have to do is remove the torque cover, slide off the housing cover, and then you just go ahead and utilize the torque adjustment mechanism and rotate that over to your desired torque. As you can see, we have a torque value on the CP2611 from 2 to 10 foot-pounds of torque. Once you achieve the desired torque setting that you want, all you have to do is slide back on the housing cover and tighten down the torque cap, and you are all done. The next step in the process is to demonstrate how you utilize a shut-off screwdriver. We're going to do this in a cabinetry type application. We're going to start off by having the screwdriver set at approximately 1 foot-pound of torque. As you can see, the clamping force on the two pieces of wood, we have not achieved that yet. So we will have to increase the torque on the screwdriver. We'll approximately increase this to about 3 foot-pounds of torque. As you can see, the clamping force has been achieved at the 3 foot-pounds of torque. And the nice thing about a shut-off type style clutch is it does not allow the tool to run anymore once torque has been achieved and the air is bypassed on the back of the tool. Now we're going to show you what happens when you have too much torque on a shut-off clutch. As you can see, with too much force, the screw went through the end of the one piece of wood and the two pieces of wood came unattached. The next clutch type I'd like to discuss is the cushion clutch. And this is a great tool for general maintenance and assembly because it has moderate torque precision. One of the other key benefits of a cushion clutch is that when torque has been reached, it makes an audible ratcheting sound to let the operator know that torque has been reached. Now I will show you how you adjust the torque on a cushion clutch. I have here a CP2822 along with your standard Allen wrench and your lock pin. The first step in the process is to take your lock pin and insert it into the hole. The next step in the process is to take your standard Allen wrench and turn the tension spring until you achieve the proper tension on the spring to get to your desired torque value. Once that has been completed, you want to remove the Allen wrench and the lock pin, and you've completed the process. We're going to start with the torque setting set at its lowest value to show you the outcome of that. As you can see, the screw is not all the way inserted in the material, and you heard the ratcheting sound that alerts you that the torque has been achieved. Now we're going to demonstrate the cushion clutch at the mid-level setting of the torque range to see what the outcome will be. As you can see by the ratcheting noise, the proper torque has been achieved at the mid-level torque range of the cushion clutch screwdriver. Now we're going to demonstrate the screwdriver at its highest torque setting. Due to the screwdriver having too much torque, this has caused the base material to strip and loss of clamping force. This is the conclusion of our demonstration. My name's Joe Jackson, and I'd like to conclude by saying thank you for taking the time to watch this video today. And if you have any additional questions regarding the topics that we discussed in this video, you can contact our customer support team at the email and number shown, or you can go to our website, cptools.com, and look at our whole portfolio. Thank you and have a great day.